So hello everyone, my name is John Turner. I'm an SRE at Squarespace, and I want to know by show of hands how many of you write code? Cool, good many of you. Of those, how many of you have like a review process for that code? Okay, it's most of the same people, that's good. How many of you like that process? Wow. Okay, well hopefully this will be a little bit of therapy then. I'm going to start with a sentiment of mine that hopefully is not too controversial, but based on the show of hands, maybe it is, which is that code review is useful. Code review provides us with a couple of different opportunities. It provides us with a means of ensuring that there's higher code quality, and that's the one that all the blogs talk about, right? More eyes on code means fewer bugs. But I think that there are actually more important aspects of it. It provides this really cool communication platform to talk about code. And oftentimes it provides us with an opportunity to teach, and to teach in a way that has really immediate practical application. Because no matter how much theory you throw at somebody in a code review, they're then going to have to apply that to the code that they're writing. And then that code's going into your production pipeline. And I think that if you agree with me that code review is useful, you might also agree that having a strong culture around code review is useful. Now, when I'm talking about culture, I'm talking about the set of shared attitudes, values, goals, and practices that characterizes an institution or organization, and in this case, it characterizes how we do code review. And attitudes, values, and goals, super more important than anything I'm going to talk about today. But that's a much more nuanced talk, and it takes way longer than a half hour to talk about. So instead, I'm only going to talk about practices. But I want you to keep in mind with practices that practices have a value system that back them up oftentimes. And they have some stated goals, and they normally have some attitudes behind them. Now, you can definitely divorce practices from their intended meaning. If you don't believe me, Google the word agile. But properly done, putting certain practices into place can help you influence your culture. So today I want to talk about influencing that culture, and I want to talk about it from the perspective of organizations, code authors, the people that actually write the code, and the people that review the code. So to start with organizations, I'm talking to the engineering leadership in the room, the staff engineers, the engineering managers, the people who are the flag bearers of culture, but still have their hands very, very deep in technical work. And I want you to be intentional about your culture. So whether you like it or not, culture is going to happen. People are going to develop values, they're going to put into place practices, yada, yada. That's just the nature of putting human beings together and asking them to do something. But you can either sit back and go, well, that's just how it is, and we'll see what happens. Or you can try to be intentional about your culture and try to steer it in a certain direction. And to me, the best way to steer your culture is to communicate it. Publish your values, publish your goals, the expected attitudes, the practices. Say, here is how we do code review. Here is why. And here are the expected attitudes that we expect you to have. And you don't have to do this alone. You can establish a community of experts within your organization. Now, there's two types of experts that I think are really helpful here. Language experts are those people who are the 10x, ninja, rockstar, guru, whatever other LinkedIn terms you want, about a particular language or tech stack. They're the ones who can give actionable advice to people on how to become better at a particular language. They should also be the ones that are driving your usage of that language. They should be establishing best practices. Now, there's also domain experts. These are people who maybe are not super great at any particular language, but they have really, really broad experience in areas like distributed systems or financial transactions, things that are really, really hard. And they should be helping out on code reviews, making sure that you're not hitting any of these rough edges. But don't just establish your community of experts. Have a way of developing new ones. Having a means of becoming a certified expert, whatever that means for your organization, is a wonderful stepping stone in your individual contributor's career path. And moreover, experts can often become gatekeepers if you don't have some way of getting new people in the door. It can be so frustrating, especially as a junior engineer, to have opinions about stuff and to be told, you're never going to be able to apply those opinions, and we're not going to tell you why. And we're not going to tell you how to get to that level. And those experts should also be training your code reviewers. Code review is a skill. It's a skill just like reading code, just like writing code. These are related, but not the same thing. And it can be honed just like any other skill. Now, at your organization, that might mean to pair people who are really good at reviewing code with people who are new to the practice and having them do code reviews together. At Squarespace, we don't have as much of a culture of doing one-on-one pairing like that, so we actually set up formal training labs. So that's the organizations. But let's go a little bit more granular and talk about code authors. These are the people that are writing the code. And I'm sorry to say that as soon as you've written this code and you've spent all this time on it, there's more work to do. But I think that the easiest thing to do in making this review a nice process is to make the reviewer's life easier. And there's a couple of ways to do that. The singular best way I found is make the reviewer's life easier by communicating as much context as possible. When you're writing code, you have all this context in your head. You have this mental model. And only some of it, I would say probably not most, is going to come out in your code. Now, yeah, you can leave code comments and stuff like that, but you're never going to capture all of it. 100% self-documenting code is a myth. And so if you recognize that the reviewer doesn't have the full context of everything, try to add as much to the pull request process as you can. So with that, I want to show you one of the most annoying things I've ever seen as a code reviewer. Now, this is a GitHub PR that has no description. Ostensibly, it has a title, because I don't think GitHub allows PRs without title, and maybe it says like fixes number 273. That's all well and good, but give me more. Give me something. Like, why did you implement it this way? And what are we doing to make sure that this bug doesn't crop up again? Like, give me something. And I want to contrast that with this PR. This was done by Julia Evans at Stripe. It's a contribution to the Kubernetes code base that they linked to in a wonderful article that they had about using Kubernetes. And I want you to notice two things here. One, there is a PR template that forces you to give a little bit of context. And Julia's writing style on this is very, very clear and very concise, right? You can imagine, even if you know nothing about Kubernetes, that if you did know at least a little bit of Kubernetes, you can sort of get what's going on here. And there's release notes, which is great. But it doesn't have to just stop at the description. You can annotate your PRs. You can be the first person to comment on them and say when you are making design decisions, when you're accruing technical debt. Show that you've thought about these things that might look a little bit weird. And you can also make the PR a more manageable size. Now, there's a couple of heuristics here that people use, and this is a really tough topic because there is no right size PR. There's a ton of wrong size PRs. So the easiest heuristic that people normally use is lines of code. So really large PRs are normally hard to review. They defy making mental models of, and that mental model is really what you need to be able to do an in-depth code review. But there are exceptions to this. If you vendor your code and you delete a bunch of libraries, that's going to be a really large PR. It's also pretty easy to review, assuming that you have tests that make sure that things don't break. There's another heuristic that I think works really well, which is to work in what are sometimes called vertical slices. And the idea behind a vertical slice is that you're shipping the smallest unit of functionality that's useful to your users, and that it makes a round trip through your entire stack. This means that if you're writing a web app, it goes through the endpoint all the way to your database and back. So that might mean if you're implementing a feature that has multiple endpoints, you ship one endpoint at a time. If you are doing library code, that might mean that you are starting at your public API and you're going through all your private methods and then going back. Working this way forces you to pare down to an MVP and to give the reviewer a PR that they know pretty much what it does. There's no hidden dependencies here. And really importantly, it doesn't introduce new private code that is not consumed in the same PR. Now I say private because your public API might be consumed by other people. And if you introduce new private code that's only consumed in tests, I congratulate you on the test coverage. That is a wonderful thing. But I have no idea why your code is designed that way. What does it do? Why does it do that? You can also make the reviewer's life easier by automating the nits. A nit is short for nitpick, and there's sort of a colloquialism in certain code reviews of saying, nit, this isn't indented correctly. This doesn't follow our style guide. Nit, this could use some tests. The idea here is don't make human beings into the things that should be in your CI pipeline. Put linters, put your test suites into your CI pipeline. Don't make people have to do that. Computers are much better at it, I promise. And then lastly, you need to know when to take it offline. Now, when I say take it offline, I mean the closest facsimile to in-person conversation that works at your company. So if you're a totally remote company, maybe that means video chat. If you're co-located, it means talking to the person face-to-face, which, as we've heard twice, is the hardest thing. And there's a couple of times in which you might want to take it offline. A really common one is if you open the review that's just been submitted on your code and it's buried you under commentary. If you have 50 plus comments, sometimes it's easier to just take it offline and say, hey, can we pair on this thing? Especially if you are new to a language or something like that, or if the person reviewing your code seems to have an implicit disagreement with your entire design or the entire reason that you're writing it, just ping them. Say, hey, can we pair on this? I promise you, you will learn a lot more. Now, the other time you might want to do it is if there is perceived antagonism. I'm only going to talk about perceived antagonism in this talk. Toxicity in code review is a real thing. It is also a much longer topic, and it is one that I'm ill-equipped to give. There's a lot of wonderful talks about dealing with toxicity. This is not going to be one of them. But I will say that dealing with toxic behavior in a code review comment is probably not going to cut it. So do what you can to deal with that in a separate way. But there's also a perceived antagonism that happens sometimes. And that happens because writing English is really, really hard. And writing English in such a way as to not hurt anybody's feelings, and even better, communicate a sense of empathy, is much harder than just writing English. And so if you get some commentary that sounds overly terse, or like maybe the person's annoyed at having to review your code, sometimes just talking to them offline, getting their body language, their tone of voice, can help clear a lot of the sort of perceived antagonism up. This is assuming that you can trust that they have good intentions. So that's for code authors. Let's talk about when you are the one reviewing the code. You have to put yourself in the code author's shoes, that they've just done a lot of work and now they are presenting it to you for critique, which is a scary thing for a lot of people. And especially it's a scary thing when you're first starting out. And so what I would like to recommend code reviewers do as much as possible is to communicate mutual respect. Assume that people can do their jobs. If you work with people who you assume can't do their jobs, maybe look for a different job. And try to understand that code review is a very pedagogical practice in a lot of ways. You get to teach people things. And so I'm going to mirror what I said about code reviewers, or code authors, and say that reviewers really need to know when to take it offline, especially if you are a senior engineer reviewing a junior engineer's code. If your instinct is going to be to bury them under commentary, don't do that. It is so demoralizing. Just set up a time to pair with them. You are going to learn a lot about how they work, and watching them work is going to lead you into these insights where you can say, oh, you don't have gofumped as your after save hook. No wonder your code's not formatted correctly. Let's do this. Put gofumped as your after save hook. You check out these static analysis tools. It goes away like a whole class of bugs. So set up a pairing session, make a list of revisions to the code, and then use that time to teach the author. Even if they're not more junior than you, use that time to discuss things. But if you are going to leave critique, please include justification most of the time. This is an example of what I think is a bad code review comment. So we're in Python, and this is a fictional thing that reads a bunch of IPs from a file, and it uses a list. And we're saying use a generator here. And for those that don't know, a Python generator is a form of iterable that sometimes has better memory performance and better CPU performance. But why? Like, what are we getting from using a generator here, besides doing what this person told us? I think that this is a slightly better code comment. We're telling the person why we think this thing, and we're giving some bounding conditions as to why we're leaving this critique. And we're leaving some documentation for them to link to later so that they can read this on their own time. And this really all goes into communicating with the author of the code as an equal. I don't care if you actually think that they are an equal, communicate with them as such. You have to bring them in and make them want to do these changes. So here's a little trick. Anytime you are about to leave a comment like this, IP processing code should be moved to its own package. This is an imperative. It means you're telling somebody to do something. Phrase it as a question. Questions invite thought. It invites people's opinions. It says, hey, fellow engineer, what do you think about this? And it allows them to give you a response that might say, hey, I've already thought about that, and here's why we shouldn't do it. You can be wrong sometimes, turns out. And then you also need to be as thorough as the PR needs. I believe that being thorough on PRs is a way of communicating respect, because you are telling the author you are worth their time. You are worth my time to review this code. And so there's a lot of different ways that you can choose to be thorough. And I'm going to show you mine. I've heard it referred to as reviewing in passes. And this essentially just means make a checklist and review the code several times. So each pass through the code is going to be a different read-through of as much of the code as makes sense. And each pass is going to have a theme to it. And it's going to be some questions that help you focus on that theme. Now, this is my code review checklist, and it's not going to necessarily always work for you. So what I want you to do is make your own, remix it as you need, and make a checklist out of it. And I divide these up into passes that you should complete every time and passes that you can do if you need a little bit more in-depth code review. The reason that I divide them up this way is that the passes to complete every time are very large existential questions about the code that you're reviewing. To phrase it another way, if the code that you are reviewing shouldn't exist in the first place, saying, oh, by the way, you messed up the indentation in line 52, super superfluous information. You don't need it. So if there are any red flags on these, try to resolve them before you start burying the person under more commentary. So the first pass is to size up things. After you've been reviewing code for a while, PRs start to have shapes to them. And this is where I say, what's the general shape of this PR? Is it a completely new feature? If it's a new feature, I'm going to start thinking about correctness of code and the design, and how do we know when this breaks, and ask a lot more questions. And I'm going to put a lot of, block out probably an hour on my calendar to make sure that I can really give this the time that it deserves. That's a different sort of shape of PR than a refactor. I love refactoring, but I also believe that refactoring needs to have a goal state to it. And I need to figure out, what is the goal of this refactor? And are we getting closer to it by refactoring the code the way that we have? That is, again, a different flavor from a one-line change. One-line changes are interesting because they often have a lot of hidden dependencies, and they can either be innocuous or disastrous. One-line changes can change some copy on your website. They can also expose thousands of S3 buckets to the public internet. They can bring down your billing system. This is also where I ask if the PR is the right size. I try to apply the vertical slices heuristic and say, how close or far are we? Now, I try not to be too picky here because saying this is slightly too long, so I'm not going to review it, is just like kind of an annoying thing to do. So don't be too terribly picky. The next pass I try to establish is contextual. What is this PR trying to accomplish? Why am I reading this? And why is this PR trying to accomplish that? What's the backstory here? What problem am I trying to solve? And does this PR accomplish what it says? Now, obviously, you can't necessarily get this through one pass-through, oftentimes. But if the PR description says, I do A, B, and C, and I've clearly only done A and B, this is where you call that out. Next pass is relevance. Is the change made to this PR necessary? Is code the best way to solve this problem? Maybe we just need to get two people in a room to talk to each other. Maybe we just need better documentation. Maybe there's a process improvement that can be made. Remember, code in a lot of ways is a liability. So somebody's going to have to maintain it. Is that what we want right now? Also, does this PR duplicate any existing functionality? Maybe the author just wasn't aware of some internal library that does this exact thing. This is where you point them to that. And are there others that should be aware of this PR? If you're designing a new feature for users and you have like a user testing team, tag them on the PRs. Let them see the evolution of this thing. Let other teams see the evolution of your code. So if there's no red flags on these, feel free to jump into passes that have a little bit more depth to them. And by depth, I mean they take longer. And not all of these are going to apply to every single change, so pick the ones that are relevant to you. First one's readability. If I understand the programming language, does the code read okay having never experienced it? I have a little trick for this, which is I read the code in my head, like actually verbalize it, and if I go, da-da-da-da-da, huh? Then I know that like maybe there's readability improvements that can be made. It's also where you want to look and see if there's any esoteric language features. In languages with very, very large specs, like say C++, invariably, there are going to be a lot of different ways that you can do something. And you need to be able to look at code and go, that technically works, but you were the fourth person to ever do it this way. And I'm not sure we need that right now. Production readiness. As we're at SREcon, this list should be much longer. So I'm just going to read off the most important ones. How do we know when this breaks? There's normally, for a lot of code, a very standard answer to this, which is something like, if there's an unhandled exception, some alert's going to go off, and there's going to be a stack trace and some logs, and that's fine. But you need to at least ask the question. And if it comes out that nobody needs to know when it breaks, congrats. You get to delete that code. Nobody has to care. Is there any new documentation that's required by this change? Documentation oftentimes will drift from the code that it documents. That seems to be sort of a truism, and maybe it's just a thing that happens like a natural law. But I think it would happen a lot less if every time we saw some changes, we said, do we need new documentation here? Are there any tests to prevent regression? Tests are not the only way to make sure that there's regression prevention. So if you don't care for tests as your way of doing that, then substitute however you actually like to do it. And is this change secure? Now, as hundreds of companies have shown us, security is very, very hard. And we cannot all be expected to be security experts. But I would contend that if you've been programming in a particular domain for a while and in a particular stack, you should be able to spot patterns that are introducing very, very common vulnerabilities. If you're writing a lot of database code, you should be able to spot if someone's just introduced a SQL injection vulnerability, for instance. And if you don't know how to spot these things, and they're not, say, covered in common libraries that you use, ask your security team about it. Your blue teamers will love you when you don't get hacked over it. Naming gets its own slide because it's hard. Do names communicate what things do? Most people are pretty good at giving names that communicate most of what things do, but side effects tend to trip them up. If you have a lot of side effects in a method or in a function, and that's not necessarily communicated in the method name, you might need to rename it. Are the names of things idiomatic to the language? If you, in 2019, write Python that doesn't use underscores in names, most people, I think, are going to call you out on that. If you write very, very short names in Java or very, very long names in Go, it's just not idiomatic to the language. And then, do the names of things leak implementation details? You'll often see things like IP array as a variable name. We don't need to know that it's an array. That's how it does something, right? Now, sometimes people use this when they need to get over a lack of type system, and that's cool. You go between you and your company for that. Gotchas is another list that should basically grow to infinity as your career goes on. This is everything that you've been bitten by in the past as a programmer. So what are the ways in which added or changed code can break? This is different from knowing when it breaks. This is how does it actually break? This is saying in a Ruby PR, what if this is nil? Is this subject to any common programming gotchas? There are certain gotchas that just happen in a bunch of different languages that you basically learn to figure out if it's going to happen. I'm talking about things like transposition errors, where you swap the order of arguments, off by one errors, things that cause memory leaks, dereferencing null pointers. And is spelling correct and consistent? I have a very pragmatic reason for wanting spelling to be correct and consistent. It makes code search a lot easier. One time, I was digging through a Java library, and it seemed to have been written by people on, say, both sides of the pond, because the word cancel was spelled both with one L and two at random places throughout the code base. It made code search impossible. I could not figure out what I needed to look at. And lastly, there is a language-specific pass. This is where I ask, is the code well designed? I think that there are a lot of sort of universal design principles in code, things like solid. But how they actually manifest tends to be very, very language-specific. So hopefully, you're a language expert when you're doing this pass. And you can say, like, this is not well designed as per the spec of this language. Is the code idiomatic, not just names? Are all the components idiomatic? Are any new patterns being introduced? By patterns, I mean patterns of usage in that code, solving new problems. When somebody solves a new problem in a programming language and they're the first person to do it, somebody else is going to copy that. And you need to be OK with that. And if it's not a pattern that you're OK with people copying, you need to call that out. And does the code fall into common pitfalls for the language? So no language is perfect. Every language has its rough edges. You need to be able to look at it and say, oh, you're using a quadruply nested dictionary comprehension in here. Let's not do that. So like I said, this isn't the full list I use. However, I did put the full list that I do use at this address. And so I just want to leave you sort of with a thought, which is that when somebody asks for a code review, they're giving you an opportunity. They're giving you an opportunity to engage with them as a fellow engineer, and they're giving you an opportunity to teach. So please don't waste that opportunity. Thanks.